Awesome. So we can start.
Everyone?
Do you want to introduce?
Yes, everyone, let's learn more about DroneD.
Thank you very much, Bethany. So my name's Justin Venus. I'm a senior application engineer with Orbitz Worldwide, a leading online travel agency. I started my career with Orbitz about 6 years ago as a system administrator in our network operations center. And over time, I progressed to the engineering department. So that's a little bit about me. What I'm here to talk to you today is DroneD. DroneD is something that we just open sourced at the beginning of the year, but it's actually been a piece of technology that has ran our flight search environment for 6 to 7 years now. And our flight search environment is huge. It's very complex. It changes almost hourly to load new information that customers may be interested in for fares and pricing and all that other fun stuff. It also can take business rules on demand. But this is a service that you, the audience, would be exposed to. You know, if you go to Orbitz.com or Cheap Tickets or any of our business sites, you would actually end up searching this flight search farm. So we can't make changes to the farm that impact our customers negatively. What's that? Oh, sorry. So we can't make changes that impact our customers negatively. We have to be able to keep this thing up all the time, no matter what the problem is, and you have to be able to search. So DroneD came in. It was developed by a guy named Chris Davis. You guys may know him if you've ever seen the Graphite project. It's another open source project that Orbitz released many years back. So the problem was, at Orbitz, this flight search environment used to be incredibly fragile. It still stayed up, it still served the customers, but it was an administrative burden to the company. In our network operations center, we used to have to dedicate an admin per shift, the entire shift, just to babysit this environment. And there were thousands of applications here. What this ended up doing was creating one-off shell scripts, Perl scripts, and otherwise unmaintainable utilities. So we're going to go over what DroneD's not and then what DroneD is. So DroneD is not a utility like CF Engine. It's not a utility like Puppet. It's not a utility like Chef. It's not meant to compete with Glue or a satellite server. And it's not like a Tomcat, so you don't run other applications directly inside of a DroneD. So what is DroneD? DroneD is a programmable model. It manages environments. I got to remember to hold this microphone closer. It encapsulates applications. DroneD is a monitor agent. It's a service container. It provides rich APIs for writing services, network communication facilities. It has many messaging facilities. It's built on the Twisted framework. It's a command and control system, and it's how Orbitz runs our flight search environment. Over the last 4 years, we've only had 30 minutes of downtime during a scheduled maintenance window because of this automation. So one of the things that you have to have in order to work with DroneD is you have to have a concept of what an environment definition is. When we talk about an environment, we're talking about servers and software. And you may think in the real world, that's not enough to describe a real world environment. You know, you may have, you know, things like compute infrastructure. You may have virtual groups. You may have, you know, region or customer specific applications that all have to work together. And the list can go on indefinitely. A lot of these differences in an environment are captured in configuration, and DroneD provides a configuration system that we call Romeo. It stands for Relational Object Mapping of Environment Organizations. What does this mean? You know, it's supposed to be human readable. It supports encrypted data. It provides you a concept of what is in your environment, what should be there, so that you can reconcile that environment and make it the way it should be. It has open APIs. It's actually YAML, and it's got a little bit of extra syntactic sugar mixed in so that you can write a YAML file, define some labels, and then import that file into another YAML definition and use its anchors directly. So if you can think of a way to define all your applications or mount points or whatever localized resource that you would need, you can bring it right in to another environment description so that you don't have to duplicate a whole bunch of configuration. So this is an example of what a very basic Romeo environment description file would look like. So we have an environment. The artifact label is really just arbitrary. That label doesn't matter if you pay attention to the label beside it and the way it's anchored inside of the server definition. You have services, and then you can define any other key value pair that you want, because Romeo maps every key value relationship and does automatic deduplication, so you can have multiple environment definitions, and if you have the same keys between multiple definitions, you can relate environments even though the files are completely separate. Romeo is meant to be distributed, so every server in your environment would get the same configuration, and that's a job for something like CF Engine or Puppet or Chef to actually make that happen. DroneD can consume this, and there's a little demo utility that comes with DroneD called RLS, which is just Romeo list. You can submit queries to it and find relationships about different things. It also provides some higher level APIs, so you can write applications that can consume Romeo data directly. It's relatively fast and lightweight. So if we look at an artifact definition in DroneD, we'll notice immediately we have an instances value. DroneD's multi-instance aware by default. You can run no instances, one instance, as high as you can count. Class is a special little piece that DroneD uses to determine how to load a plugin. If you set it to null, you're effectively telling DroneD, yes, there's a definition for this application, but don't do anything with it. If you don't set that key at all, it'll load a generic backend, which will handle 99% of standard Unix utilities. You could actually run top under DroneD and have it redirect its output to a file, and that's kind of weird. I don't know why you'd want to, but it does work. So your startup info defines what startup environment variables. If you are familiar with Linux and you type env on the shell, key value pairs, just like you would see in env. Start command is the fully qualified path to your binary that you want to run. Start args are your positional arguments that you want to run. Since this is evaluated as code, you can use expansion, so you can use Python syntax to parameterize strings. And when you bring in your plugin can actually fill in the blanks if you have to determine your information at runtime on how to actually start your application. Shutdown's similar. The short name is the name that DroneD will reference this application as whenever you want to use its command and control facilities. So let's say we named our app Test App. On the command line, it would be referred to as Test App. Full name is mostly there if you want to write like package management plugins so that you can say that this is a 64-bit version of this package and this is the name of the RPM. A service is just some arbitrary event that you want DroneD to run for you, and it has a name and you can put keys on it or whatever. So that's a quick overview of that. So let's do some work and let's talk about how DroneD can help us do some system administration. So DroneD runs an event loop, and it runs services. One of the default services that it runs, if you have a definition for your application, is an application service. The application service's sole job in life is to load application plugins and check the status of those applications. A couple of the built-in features that you get are start, stop, and status, because that's always common to your applications. Then you have an enable and a disable. That's not actually wired to do anything but fire an event, which you can subscribe to, and you can take whatever action you want on enable or disable. Like maybe you know how to talk to your application and make it shut down a listen port, but still keep the application running. You could wire that in right off of that one event. It supports custom actions. It's got a method called expose and unexpose that you would just put in your plugin, and you just fill out the API, give it a callback hook, and it's ready to go. So DroneD has a command line utility called Drone Blaster. Since DroneD is written and twisted, it's completely asynchronous. So if you put two servers on the command line, it's going to talk to both servers simultaneously. It has no concept of you want to pace this. So you could write a shell script that wrapped around a mechanism to read Romeo, figure out how many servers you have, and then dispatch the commands. Now, Drone Blaster will sit and wait for a response from the server, but the server can take many, many requests simultaneously. So at this point, I'm going to stop for a second. I'm going to show you a little video. I know we're running a little low on time, but this shouldn't take very long. So let's stop here and blah. And come on, come over. Oh, you're not going to let me see that, are you? Sorry, I thought that thing would minimize for me automatically. Oh, and it still won't. There we go. And F11 and play. So what we're seeing here is DroneD supports out of the box a XMPP interface, and it supports command line. If the video would actually play. There we go. So first thing I'm going to do is I'm going to talk to a server. And let's see. We're going to ask it for the servers that it knows about. It got this information from Romeo. And now we're going to switch context. We're going to ask this DroneD that we're talking to talk to another DroneD over the Jabber interface. Now, Jabber interface is one-to-one. If you could extend it to do multi-messaging because Jabber supports it, but by default, it's one-to-one. So we just ran a quick ping command, and now we're going to run a shell command to show that it is running on the other machine. We got a signal event from the subshell leaving. And I typed a lot slower than what I would like to speak at. Come on, Justin. All right, so we're going to show the host name of this box, and then we're going to run a Drone Blaster command using a specialized utility called HLS. HLS isn't distributed with DroneD core. It's just a example on how you can write an application that talks to Romeo or reads Romeo's API. So we just asked for the information from all the servers. By default, Drone Blaster only reports on the description field. There's actually structured data that gets passed back so that you can parse it. Let's see. Yeah, you don't care about that. I already told you. So if you submit a help command, DroneD will show you all the actions. Help works even on itself. You can ask any application that or any service for its help documentation. If you run it with no arguments, it'll tell you what its help documentation is. In a moment, if I ever get around to it, I'll actually shut down an app and show you how the messaging immediately hits Jabber as well, because we subscribed to all events earlier. So, blah. So, it did fire an event. When we start the app back up, it'll fire an event again. And I just cannot believe how slow I typed on this thing. I apologize for that. Speed up. All right, we're going to start the instance. The instance comes up, get a notification for it. The important part to note is if it can fire an event that you can send to a Jabber client, you can also capture that same event and send it over SNMP to some sort of trap server and notify a administration team that something happened. Application went down, application started, application crashed, whatever event that you want to throw. So let's get out of that. Let's stop and let's go back to the presentation. All right. So we mentioned before that it's asynchronous. So one of the things that I've tried to stress to a lot of people is when an event happens, you don't really know when it's going to happen ahead of time, and you don't really have an idea on when it's going to finish. So DroneD does provide some synchronization APIs that work well with Twisted to avoid problems like don't remove a file before you're done reading it, because that would be bad. But if you message a whole DroneD environment and say, stop all the apps, it's going to stop all the apps as fast as it can. If you tell it to start all the apps simultaneously, it'll start all the apps as fast as it can. Now, this may be good for a recovery situation where you need to bring the entire environment up really quick, but if you've got a single contention point, like a database, that can only take so many reads, it could be really bad, and it's just something to keep in your mind. So that may be nice and well, but the out-of-the-box functionality probably won't do everything that you want. So DroneD provides APIs on how to write services and application plugins so that you can extend it to fit what you need it to do. So DroneD, as I mentioned before, uses the Twisted framework, and it currently targets Python 2.4 through 2.7. As soon as Twisted supports Python 3, we'll be right there with them. DroneD in Romeo uses a special data model called entity component. You may have heard about it if you've done any game development. It's what's typically used for game engines, where you would assign an object a UUID or some other unique identifier that allows you to look up the object and put it in the right context. Well, we don't use UUIDs. We actually use constructor arguments on the classes, and we'll get into that in a minute. So I'm going to skip this brief overview of Twisted because I know we're under pressure for time. Just be aware that Twisted uses deferreds, callbacks, and airbacks. I'd really like to talk about this, but I'm just going to skip it for the amount of time that we have. So, models are absolutely critical in DroneD. Why do we need models? We want to be able to model objects in the real world. So let's take a look at this class for a second. And if you look at it, this is the way a normal piece of Python code would work. In our example, we're using stock tickers. And what we're saying is we're going to instantiate one stock object and then give it the same exact parameter a little bit later, and the ticker symbols are the same, but X is not Y, and the prices are different. And if you look at that and you say to yourself, well, there's nothing wrong with this, you're thinking too much like a programmer. What we're trying to say here is we want our stock object, when it's called OWW, to be OWW. We're modeling a stock. There can only be one stock ticker, and it can only have one price at any given point in time. So how do we do this? You know, how do we get stock OWW is stock OWW? We want this to really, really be true under the model circumstances. We want to be able to say that a server, you know, myapp.example.com is myapp.example.com, no matter where it's used in our program. And we don't want to track these objects because that's expensive. There's a lot of boilerplate code. The original DroneD code base that's still running our environment was over 150,000 lines of code. The open source version, which makes extensive use of models, is 23,000 lines. We were able to purge almost 75,000 lines of code just by introducing this. So one of the neat things about Python is when you import a module, it's a singleton. It gets written onto the sysmodules dictionary, and everything inside of that module is effectively a singleton. Every class that hasn't been instantiated is a singleton. Instances, however, when you instantiate them, become unique. So we can use some neat little tricks with meta classes to be able to track the object when it's being created. This is all kind of under the hood stuff, and you have to understand how Python actually creates objects, but it's just a meta class. It hashes the arguments and it puts it into a weak reference, and if it's no longer referenced, it automatically clears it. If you hold a strong reference to it, you can actually delete it behind the scenes with a class method. By default, it caches all models. You would actually have to put a piece of class data that said that it's a reapable object, and you can see that in the code. So a very quick justification for why we want to use these models is it's really convenient not to have to look up objects or pass them around. Like I said earlier, it eliminated a tremendous amount of boilerplate code, about 75,000 lines, in fact. The convenience actually allows us to think of our objects as nouns and be able to make more English-like expressions about our objects. And that's just, you know, kind of a personal favorite there. So entity is our base class that we use for our models. It uses the parameterized singleton, and it allows us to finally make all of this true. So let's see. Yeah, so one of the things that's really, really important with the models is you have to pick your constructor arguments really, really carefully, because you want to be able to look up your objects easily, and you don't want to put any more information in your model's constructor than what's absolutely necessary to later look it up. So if you were going to model a person, you wouldn't model a person by their first and last name. You'd model them by their social security number, because that should be unique. Now, if you wanted to make the assumption that there was only one person with a first name, last name, you could use first name and last name as a constructor argument. You could use a server host name as a constructor argument. You can use an application name, because there should only be one HTTP application. There may be many versions of it. You may have many instances of an application, but you would only have one application with a given name. Another thing that entity gives us is it gives us automatic serialization and deserialization methods, which is used internally by DroneD's journal service. The journal service runs periodically and checks for any serialized objects, or any objects that are serializable, and puts them to disk. So if your DroneD goes down, you can bring it back up, and it will be in the same running state, so it doesn't have to learn all over again. When that journal service runs, it saves a new journal each time, so you can actually roll your journal history back and put your server in a previous state. So another little convenient piece that DroneD provides in its entity model is an object descriptor. An object descriptor is just a generator that gives you all of your models of a particular class. So you can just iterate through them. So if we instantiated a whole bunch of stock objects, we could print them all with just that amount of code. And let's flip. So we actually use the property descriptor quite extensively inside of our model code. It saves us having to keep track of other pieces of information that aren't necessarily needed. Excuse me. What this example allows us to say is that every app is supposed to run on a given server, and that server has a set of server attributes that we can look up against. The server class has an apps property, and all it does is enumerate the app object and pick the one that matches based on what should run on that server. And I'm going to skip this for brevity's sake. So DroneD is largely a reactive application, meaning that it doesn't do anything on its own. That's what services are for. Services make DroneD do something. External stimulus makes DroneD do something. If you send it a command and ask it to shut down the apps, then it will go and execute the code to do so. If your application crashes and you don't have any service running that will catch the event for the application crashed, well, then it just doesn't do anything. But DroneD does have a few facilities built in to pass that message back to the application plugin, and if it's wired in configuration, it can bring the application back online if you choose to let it do that. Of course, you can also override that behavior and do anything else that you want to do. Services should not affect other services if they fail. When DroneD starts up, it starts all services. If a service crashes, it'll continue running and start all the other services because maybe you're doing development. Services can be stopped at runtime, disabled so that they won't start back up. A service that's marked as disabled and not meant to run on startup can be started by an administrator later. You can run one-shot services, or you can run services that run all of the time. So to become a service, you have to implement an interface. We do make use of ZOP interfaces inside of DroneD. That's how we do a lot of our loading of code, so that you don't have to write anything. You don't have to write any complicated loading logic, I should say. You adhere to the interface and you put your service in the expected location, which is in the services package, and DroneD will automatically load it up for you if it has the interface implemented, which it has to call out. So the service definitions aren't specific to a class or a module. They can be either or. If you've ever used ZOP, you'll kind of know what I'm talking about. You can actually say at the module level that this module implements this interface, and if that's the case, it will only load one service. But if you want to load many services from the same file, you would implement them as classes and say that the class implements this service. The bare minimum API is install, start, stop, and running. So you may be sitting there and thinking, but doesn't Twisted already provide us with a service mechanism? And you're absolutely right. Twisted does provide us with a service mechanism, but it's geared, in my opinion, to network services. And it feels kind of clunky when you want to write something like an application management service or a monitor service. But with install, what it actually does is it's passing the parent service from the reactor when DroneD starts, so that you can run other Twisted services from inside a DroneD service. So the Jabber service, for instance, is actually a twisted service that's wrapped around this API for consistency. It passes in the parent service, it binds it, it registers it, so if the reactor shuts down, the service cleanly stops. Let's see, blah. And then we have an application plugin interface. This particular example extends our default application plugin so that when the application starts up, it'll query the RPM database, and it will pass you back the version into your model, because that may be useful if you want to know what version of some application is running. Now, DroneD doesn't make the assumption that it's going to be on a Red Hat box, so you would actually have to implement that yourself. It does have a small piece of service code that's in contribution that is an expanded version of this with better error handling, and it's actually documented. I took most of the comments out so it would fit on the slide. So to be an application plugin, you have to implement an interface and you have to be in the right location. One of the really neat things about using ZOP interfaces is we don't have to inherit from application plugin to be an application plugin. In this particular example, we do call the start instance from the application plugin, so we do have to inherit from it, because we actually want its functionality. However, if we would have inherited from object and fully implemented our start instance, what would have happened is when the plugin was loaded, all the missing API would have been loaded in by DroneD automatically for us through its adaption mechanisms. So yeah, let's actually see some demos now. If I can find my video again. Where are you? There we are. And of course it looks a little goofy. All right, so this service that I want to show you is a remote config service. It's a little built-in. It's kind of just a demo. What it does is it allows you to query a DroneD server over HTTP, and it will show you your Romeo data. By default, it transforms the data into JSON, but it can also put the data out as pickle or YAML. So it uses RESTful URLs. First thing that we're going to do is we're going to show that this server has a host name. And then I guess I changed my mind on what I was going to do. All right, so it'll help you through the whole way. It'll show you what your key values are for different pieces. Using HLS again, I'm asking, based on this type of server, to show me my environment. So, all right. So I put in my environment name, run it, bam, there's my environment as JSON. I don't know what I'm thinking about here. All right, that's all the host names that are part of this environment definition. Kind of a neat part about this is it'll find the key anywhere in the path and relate it to the closest node. So what we could do is we could actually walk down a server tree and we could ask for a very specific piece of information from a given server, and then we could actually back up the tree and give that same key and get all the relations to that name. So let's see, what was I doing there? Oh yeah, so we're going down the server query path, which basically is just listing our servers. We give it a name and it will come back and give us our server. Now there's a little wraparound hook in there that if we say, give me the environment, then it'll flip back to its actual environment so you can query higher members, which is what we did right there. Then we just asked for the environment name. So let's see, how many seconds do we still have on this one? Are you not going to show me? All right. Oh, right there, we just pulled down, I guess, in pickle format. Yeah. It's just showing the format outputs. And then we'll ask for it in YAML, and then I think we're done with this one. by the way, all these objects are being calculated at runtime, not pre-cached. So all those relationships were actually looked up on the fly. And this is a really slow box, actually. All right, just pulled the server definition in pickle. So as a little thought experiment, why would this be important for you? If you've ever worked with any systems like CF Engine or Puppet or Chef, you always need an external data provider. So if you're going to take the time to run a DroneD to actually manage a given set of servers and you need to do deployments, it's really important to have a relationship between what you're going to deploy with one deployment system versus what you're actually going to run with an automation command and control system versus what you're going to actually be monitoring and trying to reconcile. So this little service was a concept on how we could query for our information, and then it's up to the end implementer to actually figure out how to make use of that information. So maybe you have a CF Engine class. I'm going to talk to CF Engine because that's what I know. And you run your bundle and you're evaluating your vars, and you need to know what your host is supposed to run. So you could just make a quick wget call out from the local machine because wget's going to be installed. You pass the information, you get a string back, you do a regex match on it. Oh, now I know my environment. All right, now I can take that piece of environment information, I can go ask for other relationships like what server group am I part of? What applications should I run? What other services should I be pulling? And what that allows you to do is it allows you to write really, really simple, specialized bundles that are just switched on and off based off of external configuration. Of course, since it's JSON, you could use Chef or Puppet to be able to pull the same information in. In the RESTful URL, the keys are case insensitive. They don't care. DroneD will just figure it out for you. And let's go along. So, all right, so what this is this is a little piece of DroneD code that's not open sourced, but it's just to show you what you could do with a DroneD. So we're doing a real-time heads-up display, watching part of our flight search environment. This one actually happens to be a little staging environment. What we're going to do is we're going to shut down an application and see it show up as down in the interface, bring it up real quick, and see it recover, and then I'll kind of show you all of them running side by side. And the box that I'm working on is actually a really, really old DroneD. It's the original DroneD. The new one and the old one that runs our flight search environment can both talk to each other, even though they're completely different beasts. La, la, la. Yeah, that's an old DroneD. That's a new DroneD. Fast forward. All right, so we checked the status. We shut it down. It immediately showed up in our little chart there with a little red bar. Unfortunately, you can't really see how clear this is. It actually says that we're missing an instance right here. So we'll go ahead and re-enable that instance and watch the logs. Instance already fired back up. And it should pick it back up in just a second. Oh, there it is. Done. So that's just an example of how you could use DroneD to do a real-time heads-up display. And I think I'll actually show you the whole environment overview just real quickly to give you an idea on how large the scale is. Blah, 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 blah. Yeah, the development environment's always broken. Come on, take your time. And then that's all of it. So if you notice, there's some little blue graphs right there. DroneD also has native integration with Graphite. So it'll talk the pickle format to Graphite or line reader. It encapsulates the data in a model that's agnostic to Graphite, and then there's just a Graphite service that it ships with that knows how to read those data models and publish them to a Graphite server if you've configured it. I'm going to open this up to questions because we've got about 8 minutes left. Oh, okay. So I do apologize. I did rush through this quite heavily because of the late start time, and I cut out a lot of information. Is there anything in particular you guys want to know about what I, yes, you.
Okay, let's say if I had 25C programs, and I had 25C programs, and I had 35 jobs. I set up the system where I could put them all in there and be able to pull out different lines.
Yes. If you can run it from the command line, DroneD can run it for you. DroneD's got, and this is one thing I didn't cover on, and I'd like to take a minute to expand on this for a second. DroneD has two concepts of application management. It has managed mode and unmanaged mode. Managed mode behaves kind of like systemd, where DroneD expects to be able to daemonize the application itself, and grab the standard file descriptors, standard in, standard out, standard error, and rewrap them into daily rotating logs. And what this little piece of code does is it actually runs as a supervision process outside of DroneD, and it lets DroneD know that the application is actually up, which is really useful when you want to do things like assimilation, which DroneD does support assimilation as well. There's a special key that you can put into your Romeo config that just says assimilation pattern, and you can write a regex that the RE module in Python understands. So you can actually parameterize pieces of your command line. So if you start an application and maybe that application forks away and creates a new or calls a new binary that maybe writes the version to the process table. When DroneD reads the process table through an assimilation scan, it could actually parameterize your version and be able to populate that information back into your server. So if you were interested in version information, or maybe it picks a port at random and you know the pattern, you can pull that back in and just have your application plug in, process the data, and set the information on your app instance so that you can recover it later. In managed mode, the nice thing is if DroneD goes down, your application doesn't. Unmanaged mode expects your application to fork away from DroneD and become its own daemon, like Apache would if you started it. DroneD does provide, in its contribution directory, a way to run sys5 init scripts on a Red Hat box, and it may even work with systemd. I haven't given that a whole lot of attention as of recently. But what that allows you to do is get PAM escalation through user mode Linux to actually manage a process that would be running as root and maybe drop its own privileges. DroneD by default does not run as a privileged user. And I highly recommend that nobody runs it as a privileged user because it does have that shell interface. You can disable that shell interface, but it's on by default because it's really convenient to be able to say, I have a session ID and I want to go pull through a whole bunch of local logs that may not be back in my log collector yet, and I need to find this right now, not wait 5 minutes for syslog to catch up. I hope that overkill answer was all right. Any other questions? Marco, you've actually had to use DroneD. I'm going to pick on an audience member because he actually came. Do you have any thoughts? What have your experiences been with it?
tell us what we will need to run with respect to what the situation was before? Just to frame DroneD within our company.
So before DroneD, our system administration team that is 24/7, they had to dedicate one member per shift all day to the care and feeding of our flight search environment. Our flight search environment essentially restarts once an hour. That's the way its data is loaded. The data comes out in a binary format. It has to be distributed to all servers in the environment. And a lot of times that process went wrong. So DroneD actually manages a multicast application that gets the data out to the servers. Since DroneD's tracking state, it knows what server's on what revision of this data. And so it knows how to calculate, I know how many members I'm supposed to have, I know how many members are actually there. It's safe to make this change. Let's test this change, because sometimes the data's, because it's generated by another program, sometimes that data is wrong and the application absolutely won't start on that data set, so we have to be able to test it. And DroneD does that testing for us by starting a dark instance, and then once it determines that that instance is correct and able to run, it would then proceed to roll the environment with a given pace to actually make that change take effect. Before DroneD was there to do that, we would have situations where, you know, we'd lose 30% of our farm as far as available capacity before monitoring had caught up to the fact that the farm was crashing due to a bad data set. And when these applications would cycle through and restart in about a minute, and you've got a couple thousand of them, it's really, really hard to catch up and stop that from happening, prop the environment up, and keep the front door up. Now, typically, in the old days, the environment had to be much bigger than what we were actually using because of this particular type of problem. You know, if we lost 30% of capacity, you know, that's only 20% for DR. Now, if we lost half of the environment, we couldn't satisfy our customer requests because, you know, it's only 20% of our capacity. And if we were under peak load or anything like that, the farm just absolutely couldn't keep up with the customers' requests. So DroneD provided a little bit of a safety net there. It also provided a way to get information out of these applications and get them into real-time streams so that we could do data analytics. We could know what markets were being searched heavily. We could know what our error rates were in real time. We could you know, trend our utilization and our capacity throughout the year, so we could actually figure out ahead of the curve, oh, this time last year we saw this amount of traffic. We can correlate that with other pieces of data and figure out if we need to build the environment out ahead of time or if it's okay. With the automation in place and only having 30 minutes of downtime during a scheduled maintenance window, I mean, I think that that kind of speaks for itself. Now, it can be a little bit, it can be a little daunting at first due to the fact that it's written and twisted and you've probably never seen it before. But all the codes there, I think it's pretty well commented. Official documentation is a little on the sparse side. We've made attempts at it in the past, and we shipped the documentation that we had when we open sourced it. I should probably flip you back and tell you where you can actually get the code at. So you can actually get the code from GitHub. If you just search for Orbits Worldwide, that user has the DroneD code base. And we are out of time. So any last questions? All right, thank you very much.